Okay, we're going to define a function u of t minus a to be this function. It's 0 if t is less than a, but it's the function 1 if t is greater than or equal to a. So what can you tell me about that function?
Continuous?
No, it's definitely not continuous. What's that? It's either 0 or 1. So this function looks like this. It's 0 for a while till you get right here to x equals a, and then it's 1. So anybody know why we use the letter u? Because we're running out of other letters. No, actually u stands for unit, which is a name for 1. U is the unit function. Okay. So what would this function look like? T times u of t minus 3. If I were to graph that function, what would it look like? Well, what does this u thing do? U is 0 up until you get to 3. So it's 0 up until you get till 3. What happens after you get to 3? This u function is 1, so I'm going to have 1 times t. So once I get to 3, it's going to look just like the function t. What can you tell me about the graph of the function t? It's just a line. That's right. So what's its intercept?
T.
Its intercept is 0, which would be over here. And when I plug 3 in, it would be at a height of? Well, when I plug in the number 3, t is 3, so I'd have the point 33. And then this line has slope 1. So this graph is 0 up until you get to the point 3. Once you get to t equals 3, you get the graph of this line t. Looks like that. Looks like 0.33 has slope 1.
Why this slope is 1 is because it's just the power of 1? Or why is it just the slope of 1?
What's the slope of the line y equals t?
Yeah, that's what I'm saying. It's linear.
It's linear. So what if I wanted the slope to be 4, what would I do?
Or just make 4.
I would have 4t there.
And then if we want quadratic, whatever, we show in the second top.
Oh, you want a quadratic? Okay. Yeah, we might have t squared u of t minus 2. What would that graph look like? Zero up until 2. And then at 2, when I plug 2 in, I'm going to get 4 times 1. 4 times 1 is 4. So that's the point 2 comma 4. And then what's it look like from there? It looks like the parabola t squared. So the parabola t squared goes kind of like this. So it would hit here. You'd have a little chunk of a parabola there. Questions on that?
Yeah, how do you know what the y coordinate is?
All I'm doing is I'm taking the x coordinate of 2 and I'm plugging it in. 2 squared is 4. And then this thing is always 0 or 1. When I plug in 2, it's 1. So 4 times 1 is 4. And I did the same thing here. I simply plugged in the number 3. I get 3 there. I get 1 there. That gave me the point 3 comma 3.
3 minus 3 is 1. 3 minus 3 is 0. 1 plus t is 0.
But remember, this function is 0 until you get to the point 3. Once you hit 3, this function is a number 1. 3 minus 3 is 0, I agree.
Okay.
But u at 0
U of 0
is the number 1. Correct. Seth?
Can we have a be a function?
For our purposes, no.
Okay.
A will never be a function. A will just be a number. I suppose you could have A be a function. It would make things significantly more confusing, but it could be. All right, so now I want to go the other way. How about if I give you a piecewise function, say f of t is 0 if t is less than 4, and it's 2t if t is greater than or equal to 4. What I want you to do is I want you to rewrite this function using the u notation.
What's u of t minus 4?
You're going to have a u of t minus 4. You going to have anything in front of it?
Yeah.
What would you like in front of it? How about just 2t? There's the same function. Because if I plug in any number smaller than 4, this u thing will be 0. Once I plug in 4 or bigger, this u thing will be 1. 1 times 2t will give me the 2t. Questions on that? How about if I flip these? What if I put 2t here if t is less than 4 and 0 there? Nope. It's always t minus a number. No, not minus negative 4. Good thinking. Okay, so remember what this u thing does. This u thing is 0 up until you get to 4, and then it's 1 after you get to 4. But I kind of want to flip it, don't I? I kind of want it so that it's 1 at the beginning, so that when I take 1 times 2t, I get my 2t, and then have it be 0 later.
So if you do 2t plus 2t and then have set up so that it goes to 1?
No, but you're getting closer. All right, so this one, we're going to write it as g of t. I'm going to have the 2t, and then to get it flipped, to get it to be alive at the beginning and 0 later, I'm going to write it this way. 1 minus u of t minus 4. Why does that work? If I plug in a number like 2, what's u? When I plug in 2 here, what am I going to get? 0. But then I'm going to have 1 minus 0, which will give me 1. So 1 times 2t will give me the 2t. So if I plug in a number like 2, this is going to be 1 minus 0, and I'll get the function 2t still. But what happens when I plug in a number like 6? This u thing, when I plug in 6, will be... No. This will be 1 when I plug in 6, but 1 minus 1 will give me 0, and then 0 times 2t will give me the 0 that I need. Okay, so you see that? See how that's going to work? If you want 0 at the beginning, you're just going to use the u function. If you want 0 later, you're going to use 1 minus the u function.
What if the inequalities for 0%?
What do you mean?
Because
So you're saying this one was t is greater than 4?
No, push one.
Well, it can't be switched. If this one's a less than, that one's got to be a greater than. Otherwise, I wouldn't have a function because it wouldn't pass the vertical line test. So one of them's always got to be a less than, and one of them's always got to be a greater than. Always got to be that way. Other questions?
So what does this graph look like?
What does this graph look like? That's an excellent question. Well, between 0 and 4, it's simply the line 2t. So the line 2t goes through 0, 0, and when I get to 4, it hits the point 4, 8.
And then drops back down to 0.
But then once I hit 4, it drops down to 0, and it's always 0.
So, are we never dealing with negative numbers in this? Do we just choose not to deal with that?
Typically, t will not be a negative number because typically t stands for time. And so what you can think of here is you've got maybe an electric circuit set up. You turn the switch on, power is sent through the circuit, but then after 4 seconds, what do? Turn the switch off, and then there's no more force going into your circuit. And so you see how you turn your circuit on for a few seconds, you turn it off, see how it reacts. Or conversely, this one would be at the beginning, your switch is turned off, and then after 3 seconds, you turn it on and you hit it with some power. And you see what happens as time goes towards infinity. Or, of course, maybe you want your circuit turned off for a little while, and then you want to turn it on, and then you want to turn it back off. How do you do that?
Just make a third rule.
I don't know. Let's see. So let's say I want this function, h of t. I want it to be 0 at the beginning. So maybe for the first 2 seconds, I want the switch to be off. Oops. Then I'm going to turn the switch on for 2 seconds. I'm going to have it switched on from t equals 2 to t equals 4. And I'm just going to give a steady power of 3. Throw in your favorite units there. And then after that, I'm going to turn the switch back off, and I'm going to see how my circuit behaves. All right, so how do I write that using this H notation, or this U notation? Well, the easy part is I'm going to have 3.
And then you have parentheses. And you're going to have u t minus 2.
U of t minus 2.
And then when it's 4, we want to minus 2. Then minus 1.
I think that's what we want. So
Add
look.
a third.
No, well, yeah, it's kind of like adding a third component, but not exactly. So let's think about this for a second. If t is 1, if I plug in 1, what's this first u going to be? It'll be 0, won't it? And if I plug 1 in here, this one will be 0 because it's less than 4. So 0 minus 0 is 0. We'd have 0. That would work. What happens if I plug in the number 3? If I plug in the number 3, 3 is bigger than 2, so this one's going to have a value of 1. U is always 0 or 1. So if t is 3, 3 is bigger than 2, so this one would have a value of 1. But here 3 is smaller than 4, so this one would have a value of 0. So 1 minus 0 would be 1, and I would get the value of 3. And then if I pick a number bigger than 4, like 5, 5 is bigger than 2, so this one will have a value of 1. 5 is bigger than 4, this one will have a value of 1. 1 minus 1 is 0. Okay, so you see the 3 patterns. There's basically 3 patterns. If you want 0 at the beginning, you simply use the u thing. If you want, exactly, if you want a value at the beginning and then 0 forever after that, you use 1 minus the u thing. If you want 0 at the beginning and 0 at the end and the switch to be on in the middle, you subtract the 2 u things.
And it doesn't matter the order. It has to be the first one first minus the second.
Has to be the first one first minus the second one second. Correct. So since the 2 comes first, it's the u minus 2 that comes first. Since the 4 comes later, it's the u minus 4 that comes later. Absolutely.
Alternatively, we could just say if we want the switch on, we make that the positive u value, we want it off and make it the negative value.
Yeah, I guess that's a good way to think of it too.
That way if we have multiple times, we could do it like that.
Wait, so could you chain like a bunch of this and everything on, off, on, off, on?
Absolutely. So if I wanted to come back on at time 6,
Yeah.
I would then have a plus u of t minus 6, and it would come back on. If I wanted to go back off at time 8, I'd do a minus u of t minus 8. Absolutely. I
You
could
just
have.
have to change the t value on the third or fourth one.
Correct. I'd have to keep changing the t values.
So could we use this if we say we wanted to make a sinusoidal function that was only on when the values were positive?
Yes, you could do that if you wanted to.
Is that more complicated than what we're doing?
Yes, it's more complicated than what we're going to do. If you want a periodic function, which is the kind of thing you're talking about, off for 2 seconds, on for 2 seconds, off for 2 seconds, on for 2 seconds, there's a completely different way to find Laplace transforms, but we will do that because this section was called periodic and piecewise continuous. So far, we've done the piecewise continuous. All right, so now that we know how to write piecewise continuous functions, we have a theorem. And the theorem says the Laplace transform of u of t minus a times f of t minus a is e to the negative as times capital F of s. Or conversely, the inverse Laplace transform of e to the negative as capital F of s is u of t minus a little f of t minus a. So, what's the inverse Laplace transform of e to the negative 2s times 1 over s? Well, this e to the negative 2s tells me that I need to have a u of t minus 2. And then I take the inverse Laplace transform of 1 over s. 1. All right, so that was an easy one. How about the inverse Laplace transform of e to the negative 3s times 1 over s squared? U of t minus 3 times t, not quite. The inverse Laplace transform of 1 over s squared is t, but I need f at t minus a. where a is the number in this case, 3. So I don't want t, I need t minus 3. The inverse Laplace transform of s is t, but I need t minus a, so it's going to be t minus 3.
If, let's say, it was t to a power, what we get, it would be t minus a to that power, correct?
Absolutely.
Wherever there's a t, we would plug t minus a.
Absolutely. So Jesse's question might look something like this. Laplace inverse transform of e to the minus 5t 1 over s cubed. That's going to be u of t minus 5. And then what's the inverse Laplace transform of 1 over s cubed?
1/3.
Oh, that should be a 5s. I'm sorry. S's go here, t's go out over there. What's the inverse Laplace transform of 1 over s cubed? 1/2
T squared.
t squared, because to find the inverse Laplace transform, according to the formula, I need a 2 on top, which means I need a 1/2. So I'm going to have 1/2, but I'm not going to have t squared. I'm going to have
T minus 5.
t minus 5 squared.
Okay.
So the u shift has to match the shift in your function. All right, so how about the inverse Laplace transform of s times 1 minus e to the negative 2s divided by s squared plus pi squared. What would you do? Distribute? Okay. So this is the inverse Laplace transform of s over s squared plus pi squared minus s e to the negative 2s over s squared plus pi squared. What's that?
Should be inverse Laplace transform.
Inverse Laplace transform, absolutely. Now we do each one separately. What's the inverse Laplace transform of s over s squared plus pi squared? That one's cosine pi t. Minus, what's the inverse Laplace transform of s over e to the negative 2s, s squared plus pi squared? U of t minus 2 cosine of pi. We'd like to just put cosine t there, right? But we shouldn't. We should put cosine of, we're going to have the pi, and then we're going to have a t minus 2. Again, the shift in your u has to match the shift in your cosine.
Is that t minus 2 inside the cosine?
Yes, that t minus 2 is all part of the angle inside of the cosine function. Otherwise, that wouldn't be right. Correct. Now, you go to look up the answer in the back of your book, and that's not the answer. Because the back of your book likes to play this trick. Cosine of pi times t minus 2 is cosine pi t minus 2 pi. And then you use the cosine function. So this is cosine pi t times cosine 2 pi plus sine pi t sine 2 pi. Cosine of 2 pi is 1. Sine of 2 pi is 0. So this one disappears. That one's the number 1.
And then pull a cosine pi t out of that.
Right. So cosine pi times t minus 2 is really the same as cosine pi t. So you're tempted to write cosine pi t when you do this, and it turns out if you do, you'd be correct. Accidentally. That's correct. So that's only going to work when you have the number 2. If you had the number 3 or 4 or 5 or 6, it wouldn't work out so nicely. And then in the back of your book, they probably pull the cosine pi t out. So the final answer would be cosine pi t times 1 minus u of t minus 2.
Which is like the second example we
Which is like the second example we showed
showed.
us. So this means that the switch is on for a little while, and then after 2 seconds we turn the switch off. Questions on that? Oh, but now we got to do some Laplace transforms. So far we've only done inverse Laplace transforms. F of t is 1 if t is between 1 and 4, and f of t is 0 if t is less than 1, and f of t is 0 if t is bigger than 4. So what they tend to do here is they tend to give your functions written in this notation, and before you can find the Laplace transform, you need to write it in the u notation. So how do we write that function using the u notation? That's right, because this one's off at the beginning, then it's on for a little while, and then it's off again. So this is, our function is 1. That's not very interesting. And then we subtract, so we're going to have u of t minus 1 minus u of t minus 4. So before you can find Laplace transforms, you have to rewrite your function using the u notation. So the answer is the Laplace transform of f of t is, what's the Laplace transform of 1? 1 over s. And then what do these u things do? E to the minus s minus e to the minus 4s. No, because you're subtracting, not multiplying. You can't combine those e's, unfortunately. All right, how about f of t is sine of t, and that happens between 0 and 3 pi. And then 0 afterwards. Well, once again, we have to write that using the u notation. So how do we write this one with the u notation? It's on at the beginning, we turn it off later.
Is that just supposed to be t greater than 3 pi, or is there a sign under it?
How about just greater than 3 pi, yeah. Truthfully, it doesn't matter, because what's sine of 3 pi? Happens to be 0, so they still would have matched. I still would have passed the vertical line test. So I made a mistake, but I got lucky. It would have still been right. Okay, so how do we write it with, it's on at the beginning, off later?
1 minus.
That's 1 minus. So we're going to have sine t times 1 minus u of t minus 3 pi. So that's sine of t minus sine t u of t minus 3 pi. Do we know the Laplace transform of sine of t? Yes, it's
1 over s squared plus
1 over s squared plus 1. What about this one?
Yeah.
This one we have a problem. What's the problem?
Well, we've got an f of t and we've got a u of t.
Sine of t minus a.
I need, if I have u of t minus 3 pi here, I need sine of t minus 3 pi. I don't have sine of t minus 3 pi. So what do I have to do?
Take it that way.
I have to fix it. All right, so I'm going to come off to the side here. What can you tell me about sine of t minus 3 pi?
Isn't that put the negative outside?
Well, if it was just sine of negative 3 pi, then yeah, the negative would go outside. What does sine do when you're adding two things here? In this case, subtracting them.
We have to do this.
It's sine of the first one
Times cosine of the second one.
cosine of the second one minus
Sine of the second one.
sine of the second one cosine of the first one.
And the reason why that's actually shouldn't it be plus sine of 3 pi because it's a negative 3 pi and that should be pulled out of 3 pi.
No, the since it's a minus here, it's a minus there. Now, what's the sine of 3 pi? 0. So that whole term is gone there. What's the cosine of 3 pi? Not 1. Negative 1. So this becomes negative sine t.
So it's we can switch that to plus
So we switch this. We write this as sine t plus sine t u of t minus 3 pi. And we use the fact that this minus sine t that we had here is exactly the same as that sine of t minus 3 pi. So it doesn't look like, because I have a t here and a t minus 3 pi there,
replace it.
you can just replace it if you wanted to. You could put sine of t minus 3 pi there if you wanted to, yes. Okay, but that's the tricky thing. So you're looking up your answer in the back of the book, so you don't think about that, and you write that this one is 1 over s squared plus 1, and this one's 1 over s squared plus 1 e to the minus 3 pi s. And you're looking up the answer in the back of the book, and you had a minus here, and you're wondering how did that minus change to a plus. That's how it changed, because you really had to have sine of t minus 3 pi there, which is the same as minus sine t. So I needed to put an extra minus in there, which made that a plus.
So the sine of t minus 3 pi.
So you're going to look up the answer in the back of the book, and you're going to be off by a sign, and you're going to wonder, why am I so close? Why is
So
the
it's
sign
better to
wrong?
leave it as the sine t rather than switch to this because it's easier to do the Laplace transform.
Right, I prefer to leave it as sine t because I know the Laplace transform of sine t.
That makes sense.
But there's absolutely no reason why you couldn't write it as plus sine of t minus 3 pi. And then it would look like your t minus 3 pi and your t minus 3 pi match up.
So where does sine of t?
So we would just get 3 to the e to the negative 3 pi x.
3 pi t.
So
Yes, I mean.
I don't get where sine of t minus 3 pi comes from.
In order to use our theorem about Laplace transforms, if you have a t minus a with your u, your function has to have a t minus a. So if I have u of t minus 3 pi here, I need sine of t minus 3 pi there. Your translation here has to match your translation there.
Well, how come you can just throw that t minus 3 pi in?
Yeah.
I threw that t minus 3 pi in there. This is what I needed. So I wrote down what I needed, and I used my trigonometric identity and found out that sine of t minus 3 pi happens to be exactly the same as minus sine t.
Oh, okay.
So if I want to put at this step, I want sine t minus, what I really want is sine of t minus 3 pi right there. U of t minus 3 pi. But I can't just change the t to a t minus 3 pi. What happens when I change the t to a t minus 3 pi is it introduces that negative sign.
Then wouldn't that first sine of t have to be negative then?
No, because I'm not changing this one. This one's fine. This one's not being
You're
multiplied.
still changing the problem if you just make that positive all of a sudden.
I did change the problem, but they're equal. I substituted minus t to get what I needed, or minus sine t to get what I needed there.
Okay.
So this one doesn't need to change because this one doesn't have a u attached to it. It's only this one that you need to make match.
Gotcha.
Other questions?
So I think I can see what he's saying. So it was originally minus sine t. So you're saying you want to make that a negative sine t. So wouldn't it become plus a negative sine t? Like I just feel like you're adding a negative sign, but you just do the opposite.
I'm not sure. Not sure what to say. Well, I'll tell you what, we're about out of time. We'll do some more of these tomorrow and make sure we understand what's going on. Sound good?